Today we're going to look at lesson 9.6, which is solving nonlinear systems of equations. Now, if you remember systems of equations, we've done this before, and each system has how many equations in it? Do you remember? It was back before Christmas, I'm pretty sure, so you're going to have to think for just a second. But when we talk about systems of equations, how many equations are in one problem? Two, all right? These are going to be nonlinear systems. So if something is nonlinear, that means it's not a what?
Line.
It's not a line, all right? Very good. So the essential question says, how can you solve a system of two equations when one is linear, which means that graph is going to be a line, and the other is quadratic? What kind of graphs do we get when we're graphing quadratic equations? Parabolas. And you can see right here on this screen, okay, nonlinear system of equations is a system where at least one of the equations is nonlinear. So the examples that you drew for yourself, you have a parabola and a line that are never intersecting. So how many solutions does that have? No solution. In the second picture, you have a parabola and a line that are intersecting very obviously in how many points? At 1 point, all right? So make sure on your sketch in your notes that it's very obvious they're intersecting at 1 point, which means there would be one solution to this system. And then the third picture has a parabola and a line, and that line and parabola are intersecting in how many points? Two. Very obviously, again, make sure it's obvious in your notes, but that means that this system would have two solutions. So listen, if we are talking about the points of intersection, what will our final answers have to be? If we're talking about points of intersection, what will our final answers have to be? Intercepts, or what? Ordered pairs. Thank you. All right, we're looking for ordered pairs. If the solutions are the points of intersection, our final answers are going to be ordered pairs. They're going to be those points of intersection. Now, in example number 1, it says solve the system by graphing. All right, now here's what I want to make sure you understand, because the last hour that I taught this, we struggled a little bit. You have to make sure that the points of intersection are always included on your graph. So grab your phones, go to Desmos, and I want you to plug just the first equation in first, okay? Actually, we need to plug both of them in, so that way we know which points we're actually going to put on our paper. So go ahead and plug in y equals 3x minus 15. And then before you start graphing it, go ahead and plug in the y equals 1/2 x squared minus 2x minus 7 as well. All right, get both graphs on your screen before we start plotting on our coordinate plane. Want them both on the screen before we start graphing so that we can make sure we include any points of intersection that we have. All right, so let's focus on the line. First of all, I need 3 points that are on that line. Again, pay attention to the points of intersection because we need to include any points of intersection when we graph our line. So somebody give me 1 point that is on our line. All right, we've got 2, -9. So from the center, we go right to 2, and then we go down to 9. All right, and make sure not only do you plot it, but make sure you label it as well. So 2, -9. All right, give me another point on your line. 9 would be another point. So this time we're going to go right 8 spaces and go up 9 spaces, and we're going to plot a second point. All right, very good. And again, we're going to label it. So it's 8, 9. All right, now I need one more point. Remember, when we graph lines, we want 3 points. So give me one more exact point on this line. So 5, 0. So we're going to go right to 5. And since y is 0, we're going to stay right on the line. All right, perfect. Question, did you include any points of intersection on this line? Yes. Okay, good. So we're going to draw the line. We're going to do the very best that we can because we know how great Miss Johnson is at this. Okay, put your arrows on the ends. Now let's talk about the parabola. Again, please include any points of intersection. And I understand at this point we may be overlapping points that are on the line, but that's okay because we want to graph the points of intersection. So give me 3 points for the parabola. Listen, the vertex is always a great one to give me. If you can give me an exact point for the vertex, then give me the vertex. All right, do we have an exact point for this vertex?
Yeah.
What is it?
2, -9.
Okay, perfect. So 2, negative 9, which we already have. Oh, and did anyone notice I forgot right here? Make sure you label the point 50. All right, so we've got the 2, negative 9. We've already got it there. We've already got the point labeled. What's another point on your parabola?
7, 4.
All right. Do we have a second on that one? Is 7, 4 a point? 7 and then 1, 2, 3. All right, so we're going to plot 7, 4. All right, and then we're going to label it. And I need one more point on the parabola. Give me one more point on the parabola. 8, 9 would be another point. Again, that point is on the line, which is perfect. It's already there. It's already labeled. Now we got to draw the parabola. Okay, and remember, be very careful. Make sure you draw that parabola. If this is my vertex, I got to come around here, make it U-shaped, and put my arrows on the end. Okay, now remember, to solve this system, I'm looking for the what? Not the x-intercepts. That's not what I'm looking for this time. I'm looking for the what? The points of intersection. Where does the parabola and the line intersect each other? So give me a point of intersection.
8, 9.
8, 9. Okay, for sure 8, 9. They were both on the parabola and the line, so that's a point of intersection. And where's another place where the two graphs meet? 2, negative 9. So the 2 points of intersection are the solutions to this system. Now that leads us into example 2. Solve the system by substitution. Now we all know what substitution is, all right? A real life example. If me and Emma both play basketball and we're both considered point guards for our team, we're not both going to be in the game at the same time, right? I'm going to be in there, I'm going to play, I'm going to be, dying and out of breath, and I'm going to need a break. So what's the coach going to do? He's going to substitute Emma in for me. We're the same position. We both play point guard, okay? But she is going to replace me in the game. So when we're doing substitution, we are finding out that both of these expressions are equal to what variable? Look at letter A. Y. Y equals negative 5x and y equals x squared minus 3x minus 3. So is it possible that if both expressions equal y, that they equal each other? Yes, absolutely. So for those of you who are visual, here's essentially what we're doing. We're taking this y right here, and either we're substituting in the negative 5x, okay? Or you can look at it, here's the other y. We're substituting the x squared minus 3x minus 3 in for that y, okay? However you see it, it doesn't matter. If both expressions equal y, then they equal each other. So that's why I put right under the directions, set the expressions equal and solve. So we're going to take negative 5x and we're going to set it equal to x squared minus 3x minus 3. Now, we have options because it says solve by factoring. Okay, we haven't seen that in a few weeks, but we can factor these. We can solve using square roots, possibly. We can solve by completing the square or the quadratic equation. So you have options. What is the one option, though, that will not work for this problem? And why will it not work? Square roots will not work. Why will square roots not work on this problem? There is an x term, okay? Remember, square roots only work if it's ax squared plus c. There can only be an x squared term. Very good. So for this particular problem, square roots is not an option. But factoring is, completing the square is, and the quadratic equation is. Now, here's my suggestion to all of you, because really you could all pick a different method. I would always check first for factoring. All right, if you are very comfortable with our x factoring, I would always look to do x factoring first because it's going to be the quickest of any of our methods. So looking at this problem, what do we really need to do first before we make that decision? For all of these methods, we have to get everything on one side, right? So let's move the negative 5x to the other side, and how are we going to do that? Okay, we're going to add 5x, and just make sure you add it to its like term, which is the negative 3x. So when that crosses out, I bring a 0 down, and then it equals x squared. What's negative 3x plus 5x? Plus 2x minus 3. All right, now we can decide what we want to do. Now for me, I'm looking to see if I can factor. If my leading coefficient is a 1, I'm always asking myself, could I factor this and could I factor it quickly? What do you guys think? You want to try factoring? Yes? All right, let's try factoring. Again, leading coefficient is a 1, so that's a real simple x factoring problem. What goes at the top of my x? Everybody. 2. What goes at the bottom of my x? -3. Will my signs be the same or will they be different? They will be different. And I need factors of which number? 3. 1 times 3 is 3. Now, if I subtract 1 and 3, do I get 2? Yes. So which one's positive and which one's negative? 3 is positive and 1 is negative. So 0 equals, it has to come down. What are my binomials that I get when I factor? X plus 3 times x minus 1. Perfect. But I'm not done because I got to solve for x. So how do I solve for x? Nope. Foiling will put it back into make it a trinomial. Set both binomials equal to 0. Very good. So x plus 3 equals 0 and x minus 1 equals 0. How do I solve the first equation for x? Subtract 3. So x equals -3. Now, circle, don't box. Because remember, the solutions to systems of equations are ordered pairs, right? So right now I just have an x value, so circle it, don't box it. All right, how do I solve the second equation for x? I'm going to add 1. So my second x value is x equals 1. Circle, don't box. Now, what do I do with these x values in order to find the y values? I plug them back into one of the original problems. Which one is going to be the easiest? Good. The linear equation is always going to be the easier one to choose. Okay? You can choose the quadratic equation, but why make your life more difficult if you don't have to? All right? So we're going to go back up here and we're going to take y equals -5. Now the first time through, we're going to plug which x value in? -3. So y equals +15. Again, circle, don't box because it's not a final answer. The second time through, we're going to do -5 times the other x value, which is 1. So y equals -5. Circle, don't box. Now that leaves us to write our final ordered pairs. So we just have to be careful. The first one, let's start with the x coordinate of -3. What did we get when we plugged a -3 in?
15.
Okay, the +15. And then when I plugged the +1 in, what x value did I get? -5. So my two final answers, my 2 point of intersections are -3, 15 and 1, -5. Okay, so there's one extra step on these. We have 2 x values, so we have to plug them both in and get our 2 different y values. Look at letter B. Again, we have y equals -3x squared plus 2x plus 1, and y equals 5 minus 3x. If both expressions equal y, then they are what to each other? Equal to each other. So we're going to take -3x squared plus 2x plus 1 and set it equal to 5 minus 3x. All right. Before we choose our method, what do we need to do? Let's get everything on one side. Now listen, does not matter which direction you move stuff. All right, we've talked about how we don't like to have a leading coefficient that's negative, but if we're going to use the quadratic equation, it doesn't really matter. So I don't care. Noah, what do you want to do? Which direction do you want to move stuff?
5 minus 3x over to...
Okay, so when I move the 5, I do what with it?
Subtract it.
All right, let's subtract the 5. Make sure you put it underneath its like term. And then what about the -3x, Noah?
Then positive 2x.
Okay, we're going to add it to the positive 2x, right? We're adding it to move it?
Yes.
Okay, very good. So I'm going to add it to both sides. So these cancel, so I can bring down a 0, then I bring down the equal sign. So -3x squared. 2x plus 3x is 5x, and 1 minus 5 is -4. Okay, now let's talk about our options. Does factoring make a whole lot of sense here? No, we'd have to do our AC factoring, and that's a little bit more complicated. So I would not factor if I were you. What about square roots? Does square roots even work as an option on this problem? No. Again, why doesn't it work? There's an x term. Okay, I can't do square roots if there's an x term. All right, what about completing the square? Is that necessarily the easiest thing to do when the leading coefficient is not a 1? No. All right, what about the quadratic equation? Yes. All right, so let's identify A. What does A equal? Negative 3. What does B equal? 5. And what does C equal? Negative 4. All right, now let's write the formula down. X equals negative, say it with me if you know it, negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, now letter A has kind of invaded my space, but that's okay. So X equals, let's plug in what we know. It's a negative, what's our B value? 5, okay. Plus or minus the square root of, our B again is 5, minus 4 times A. What's our A? And our C. Okay, negative 4. Gonna have to write smaller. Hold on, sorry guys. All right, it was 5 squared minus 4. What was A? And C? All right, and that's all over 2 times negative 3. All right, so X equals, do we have any double negatives? Nope, so we got negative 5 plus or minus the square root of. Now, just put the discriminant in the calculator. Don't worry about the radical right now. Just do 5 squared minus 4 times negative 3 times negative 4 and tell me what you get. Negative 23, and of course that's all over what? What's 2 times negative 3? Negative 6. All right? Now, at this point, we're supposed to figure out the two numerators, right? We've got negative 5 plus the square root of negative 23 and negative 5 minus the square root of negative 23. But what do you notice about this problem? There's a negative under the radical. And since it's a square root problem, can I work with a negative under the radical? No. So what's my answer? No solution. No solution. I stop where I'm at and I write no solution. And that's my final answer that I box in. That means if I were to graph these, they would never intersect. Let's move on to example 2 where we talk about elimination. Again, if you go back to what we've done in the past, remember with elimination we had to choose a variable we wanted to eliminate. We had to multiply one or both equations so that the coefficients were the same number but had different signs. Is that ringing a bell with everyone? Yes? No? Yes. All right. Well, look at your problem. Y and Y are already the same coefficient, right? They already have the same coefficient. So the only thing we have to do is multiply one of those equations by negative 1. So you'll see right under the directions I said, multiply one equation by negative 1. Doesn't matter which one. So I'm going to go ahead and do the second equation. Again, I'm going to do the linear equation because it just makes it easier. That means I have to bring down the first equation, y equals x squared plus x. Now, when I multiply the second equation through by negative 1, essentially my signs are changing. So positive y is going to become negative y. It's going to equal, x is going to become negative x. Now notice what I did. I moved it over underneath its like term. And then positive 5 is going to become negative 5. And negative 5 doesn't have a like term, so it's going to be there by itself. And then I combine the two equations vertically. What is y minus y? 0. So I cross it out, bring my 0 down. It equals x squared. What's x minus x? 0. So do I need to bring the 0 down this time? No. This time I've got other things over there, so I can just bring down the x squared and, of course, the minus 5. Now, the problem is set equal to 0, so now again I have options. Do I want to solve with factoring, square roots, completing the square, or the quadratic formula? Square roots. Why square roots this time? Because there's no x term. So absolutely square roots would be the quickest and the easiest. Now think back to your journal entry. How do I work this problem? What do I have to do first if I'm going to solve using square roots? I got to get the x squared alone, right? So how do I get x squared by itself? I'm going to add 5 to both sides. Now you're going to notice I'm going to go ahead and just put the x squared first, and it equals, what's 0 plus 5? 5, all right? No signs changed. I literally just took the problem and flip-flopped it. Okay, I can do that. That's okay. Now, I got to finish this because I want to solve for x, not x squared. So how do I finish solving for x? I'm going to take the square root of both sides. Now, guys, if I put the radical into the problem, which I'm doing, what else do I have to put into the problem? Plus or minus. All right, so the square root of x squared is x, and it's going to equal plus or minus. Now let's go ahead and put this in decimal form, all right? And let's round to the nearest hundredth. So what does that give me when I round that to the nearest hundredth? 2.24. Awesome. Now I'm going to circle, not box. How many x values do I have to plug back into one of the problems? 2. Okay, good. Recognize that is a positive 2.24 and that is a negative 2.24. So which equation would you guys like to plug this back into? Okay, very good. Which one's the linear?
X plus 5.
Good. So y equals, in place of x, we're going to do a positive 2.24 plus 5. And what does that give me? Okay, and remember, it is approximately. And what is it? 7.24? Okay, circle, don't box. And we're going to do it again. This time I'm plugging in a negative 2.24 plus 5. And what does that give me? 2.76. Circle, don't box. Now I've got to write my two final answers. So what's the first ordered pair? 2.24
and 7.24.
and 7.24. All right, someone other than Gage, give me the second one. Negative 2.24 and 2.76. Very good. So again, if I were to graph these, there would be 2 points of intersection. Multiply the linear equation, which is the first equation, through by that -1. So right underneath that second equation, what's the new equation when we multiply through by -1? Negative y equals negative 2x. Make sure you're putting it under its like term of x, and minus 5, which goes under its like term of -4. So what's y minus y? 0 equals negative 3x squared. What's x minus 2x? Okay, negative x. All right, sorry, let me fix that. All right, so 0 equals negative 3x squared. You said negative x? And then -4 minus 5? -9. All right, everything's on one side, set equal to 0, so we've got options. Claire, did you guys solve by factoring, square roots, completing the square, or the quadratic formula? About it. Factoring. You've got a leading coefficient of what? -3. So factoring is going to be the AC factoring, which isn't necessarily the easiest and quickest way to factor. All right. Are you allowed to use square roots on this problem? No, because it has what term? What term keeps you from being able to do square roots?
0.
Nope. This one has an x term, so we can't do square roots. Could we complete the square on this one? Yes, but again, the leading coefficient is a -3, which means we're going to have to move the 9, then divide everything by -3, and it gets more complicated. So that leads us to the quadratic formula. Could we do the quadratic formula on this one? Always. The quadratic formula will always work. So when in doubt, use the quadratic formula. So let's identify A. What's A equal? Anyone? -3. B equals? -1. And C equals? -9. Awesome. Let's write that formula down. X equals -b plus or minus the square root of b squared minus 4ac all over 2a, or divided by 2a. Now let's plug in what we know. Negative, what's our b value? Negative 1, plus or minus the square root of, again, negative 1 squared minus 4 times a. What's a? Negative 3 times c? Negative 9. Make sure that radical goes all the way over the discriminant. And then it's going to be divided by 2 times, what's our a again? Negative 3. All right, double negatives this time. Do we have them? Yes, double negative makes this become a positive 1 plus or minus the square root of. All right, plug the discriminant into your calculator and tell me what you get. Keep the radical in your problem for right now. So you get negative 107, and of course it's divided by, what's 2 times negative 3? Negative 6. Now, if we go to figure out the two numerators, are we going to be able to? Why not? There is a negative under the radical. So at this point we stop, and what is our final answer? No solution. Again, if we graphed these two equations, they would never intersect. So no solution is your final answer. And that is lesson 9.6.